Yeah. So what we're doing now is we're finding the minimum in a rotated sorted array. So if it's a sorted array, then we know for sure that the minimum will always be at the leftmost index, leftmost position. But when we rotate it, what is the meaning of rotating? Rotating means maybe you take one element from the right, that is the largest, the first largest element, and then you place it here. This is when you rotate it once. When you rotate it twice, what will happen? You take the largest element from the left and you place it here. Now you take the second largest element and you place it here. So this is what happens when you rotate it twice. So essentially when you rotate it twice, you can just say that you take the largest two elements, the two largest elements, and then you place them here, such that the relative order also remains the same. So you know for sure that in this segment that you rotate it and place it in the left side, this is always going to be sorted, and this is also always going to be sorted, right? So similarly, maybe I can place the three largest elements and then I can place them at the front, that I can rotate the three largest elements. So what happens here is, again, you know for a fact that these two are always going to be sorted and this is always going to be sorted, right? So let's say for now that you have these 6 elements, and then I'm going to place these 3 largest elements and I'm going to place them here. Now I know for a fact that this is always going to be sorted, this is going to be sorted, okay? So now there are left so the 3 pointers that are important to us is the left pointer, mid, and the right pointer. So let me take these left and the mid, these 2 pointers. Now if I do some permutations and combinations, then I know that either the left can also be anywhere here and the mid can be somewhere here, or the left and mid both can be here, or the left and mid both can be here. This is one case, this is one case, this is another case. Now the case that mid is here and left is here is not possible, because we know that always mid will be greater than left. That is, the index of the mid is always going to be greater than index of the L. Okay, so this case is not possible. Only these 3 cases are possible for sure. Okay, so let us take the case in which the left is here and then the mid is here. Now if the left is here and then the mid is here, or let me take this case first, that is when the left is here and the mid is here. So if the left is somewhere here and the mid is also somewhere here in the left sorted half, that is, this is the left sorted half, this is the right sorted half. Now let me take the case in which the left is also here, mid is also there. Now we know for a fact that the mid index is always going to be greater than the left index, that is, the mid is going to be at the right of the left, okay, at the right side of the left. Now we know that if the left is also somewhere in this half, mid is also somewhere in this half, then do we know for a fact that just by looking at the left and the mid pointer, we can say whether this part of the array is sorted or not? Yes, because the left A of L is always going to be less than or equal to A of mid. So hence we know that this is going to stay in the sorted half. I mean, hence just by looking at the positions of the left pointer and the mid pointer, we can say that this half is sorted. The part in which the left and mid lie is sorted. Now let's just come here. That is where the left is here and the mid is here. That is in the right sorted half. Now here also we know that just by looking at the left and the mid pointer, we can say that the array is sorted. That is, this part. See, this part is going to be sorted. We know whether we are in the sorted half or we are in this sorted half. We are in a sorted half or we are in an unsorted half. Just by looking at the left and mid pointer, we can make sure. Similarly, let's come here. That is the left and the mid pointer. Now here also, just by looking at the left and the mid pointer, we can say for a fact that this is always going to be, this is going to be unsorted. You just see 5 and 2. So if 5 and 2 are unsorted, the entire array, we know that is unsorted. If 5 and 2, if it was like 2 and 5, like here you have 4 and 6. So here we know that Just because these two are sorted, the entire array is sorted. Now what I meant is, like let's say you have a case in which this and this is sorted, but maybe in between you'll have something that is unsorted. This is not possible. This is not possible. If this and this are sorted, if the elements at the left and the mid pointer are sorted, then always in between also the elements are going to be sorted. So this is possible. This case is not possible. Okay, that is because we know that we are taking these right half of the elements and we are placing them in the front in such a way that this relative order remains the same. So that is why this takes place. So now we know that one point we have made clear to ourselves, that just by looking at left and mid pointers, we can say that the element between them are sorted or not. Okay, now the next thing. Now let's take these two scenarios, that is, here the left pointer is here, the right pointer is here. Okay, now can we say that now we look at the left pointers, right pointers, these two elements are not sorted, therefore the entire element is not sorted. That means that the left pointer lies at the left sorted half and the mid pointer lies in the right sorted half. And then we also know that when this happens, the pivot element, that is the largest element and then the smallest element, that will lie in between them. So in this scenario we know that that the smallest element is in the unsorted half. Now that is, the smallest element is in between the left and the mid pointer. Smallest element is in between the left pointer and the right pointer. Sorry, the mid pointer. Okay. See, just by looking at this, we know that just by looking at the left pointer and the mid pointer, these two elements of the left pointer and the mid pointer are not sorted, which means that the elements in between them are also not sorted, and that means that the pivot index, the smallest element, will lie in between them. That is because the left pointer comes from the left sorted, that the right pointer comes from the mid pointer comes from the right sorted half, and we know that somewhere in between this rotation has occurred, so therefore this has to lie in between here. Now similarly, let's say the left pointer also right in the left pointer and the mid pointer, the half is they lie in the sorted half, but here we know that the smallest element is not present here. The smallest element is not present here because the left pointer and the mid pointer both lie in the sorted half of the larger values. Smallest element not present here. Now here you have that the left pointer and the mid pointer both are sorted, which means the entire array is also sorted, and the smallest element is also present here. Is present in between or inclusive of left and mid. These are inclusive. Maybe it's at the left, exactly at the left index also. Okay, so inclusive, left and mid, which is basically left only. Okay, because if this is sorted, then you know that the smallest element will be at the leftmost position. And so yeah, so therefore by looking at all of these we can conclude two things. That is, if left pointer and mid pointer are unsorted, that means minimum element is present in between. But if they are sorted, then we're not sure. We're not sure. Okay. So looking at all of this, let me write the code now. So the code goes like this. That is, first we calculate, so this is the function, I'm writing the code in Java. So public int find min, and you get an array A. Now here you have, of course you'll write int L is equal to 0, and you'll write int R is equal to A dot length minus 1. Next what you're going to do is, you'll store an answer. Now you'll store in infinity here. Let's come to the next one. That is while. The same thing. That's the code that we write for binary search. The same code, and you have mid is equal to L plus R by 2. Of course you can write this as L plus R minus L by 2 also. I'm just writing it like this. And now the first thing is, now we check whether the left pointer and the right pointer, mid pointer, whether they are sorted or not. Now if at all the left pointer and the mid pointer are sorted, that means the entire element, the entire range is also sorted, but the minimum element may be present here, may not be present here. If it is present here, let us just update it, the answer, by math.min of answer comma A of L, because we know that if this is sorted, then A of L will be the smallest. And next we have, so that's it. Now we just eliminate this part, that is, we're handling this case. Okay, this case, maybe the left pointer, mid pointer, they are here, they are sorted. Okay, but it may or may not be present here. If it is present here, well and good, we've already stored the value of the minimum inside our answer variable. If not, let us if not, then anyways we have updated our answer variable. We don't have anything to lose. Let us check in the next sorted half, that is the other sorted half of the smallest. That means I'm telling that the left pointer and the mid pointer are sorted, but we don't know whether they are inside the range of the large sorted half of the larger elements or the sorted part of the smaller elements. We don't know whether they are here or whether they are here. If they are here, then the answer will lie here. If they are here, then the answer will not lie here. If they are here, it will lie here. So anyways, we are just updating here. We don't have anything to lose, and we just increment it by mid plus 1. That is, what if we are lying here, then we have to of course change it to here. Okay, yes, correct. Now in case we are lying here, in case we are here, and then the mid point will be here, the left point becomes mid plus 1, and eventually what happens is the loop will end, so it's not gonna update our answer variable. So let's come to the next one, that is else. Otherwise, that means that the left pointer and the right mid pointer, they are not sorted. What does that mean if they are not sorted? If they are not sorted means inside them, in between them only, the minimum value will be present. That means we have to look only in between those two variables. So we never know, maybe what is the meaning of unsorted? Unsorted means the case that's there here. That means the value at the smaller one, the value at L is greater than the value at mid, right? And we're gonna look in between here, because we know that they are gonna lie here only. because we know that the minimum element deployed by all will lie in between because it's unsorted. Okay. So what we're gonna do is we gonna search only here. So if we are gonna search only here, then we're gonna limit our range to this. That is, we're gonna make that is, we're gonna bring right, which was somewhere here, we're gonna bring it to here. That is, now initially we were looking for the minimum throughout this array. Now we look only here. That is, the left will be where it is. You check, the mid will be here. So we're gonna make right is equal to mid. That's it. And here we close this and then we return the answer. That's it. So this is the complete code. Okay, thank you.